Okay, guys, this is Tuesday, September, I have no clue, 18. Homework is page 141, 1 through 17 odd. Question number 1. We're using this graph right here to answer the question, which of the following polynomials represents the graph of f of x? Notice that your ends are going opposite directions, so the degree has to be odd. It looks to me like there's 1, 2, 3 zeros. I don't think any of them look double, so I would say it's probably something cubic. So if you look right here, I could cross off C and D because those are both squares, so it's not C or D. So it has to be A or B. Now, if it's a positive leading coefficient, the ends would be here and here. Because these are opposite and the top one is on the left side, that means there should be a negative leading coefficient. So the answer should be B. Leading coefficient should be negative because the ends are reversed. Usually it's here and here if it's positive. If it's here and here, it's a negative leading coefficient. But it's definitely cubic. Okay, going on to number 3. So the answer to number 1 is B. Okay, so number 3. So number 3, I'm going to write this down. Y equals 4x squared minus 2x to the, oh, that's a 7. Good, I can't see that. Plus 8x plus 6. The question is, determine the y-intercept and end behavior. Okay, so number 3. Because the leading, or the degree is 7, and because the leading coefficient is 4, your ends have to go like this. Here and here. Okay, that's your ends. Odd, go different directions. Leading coefficient is positive, so the right side goes up, left side goes down. So you would say as x goes to the right, you're describing this one, y goes up. So now to describe the left side one, as x goes to the left, the y goes to negative infinity. That's this one. This is negative infinity. This one's positive infinity. Ends. Second question, what is the y-intercept? So to get the y-intercept, so this is the ends, we'll say point, point. Y-intercept. To find the y-intercept, you're going to let x equal 0. Okay? So basically it looks like this, 0 minus 0 plus 0 plus 6. So anything that has an x becomes a 0 in this problem. So the y-intercept is 6. 0, 6. Okay, that's all you have to do for number 3. Y-intercept, end behavior. And number 5 says, use what you know about the end behavior and zeros of a function to sketch a small graph of this. So I'm not using my calculator. I'm going to give a rough estimate of this. So it's x minus 2, x minus 6, x plus 2, and x plus 7. So this problem. Let's start with the zeros. This is going to have a degree of 4, first of all, because there are 4 x's in this problem. The LC is 1, so that means my ends are going to be going up, but I'm going to wait till I get my zeros in here. So my first 0 is the opposite of negative 2, which is 2. So basically you're setting x minus 2 equal to 0, so one of your zeros is 2. I'm not going to do that each time, just take the opposite of that, 3, 4, 5, 6. The opposite of that is negative 2, and the opposite of 7 is negative 7. So there are my zeros. Now, that's a very important 4 points. Those are your zeros. My zeros are, again, 2, 6, negative 2, negative 7. Now, to find your y-intercept, so degree, degree, zeros. To find your y-intercept, you're going to let x equal 0. So in the first one, basically, if you let all the x's equal 0, it looks like this. So you have your same equation, except where all the x's are. So to find the y-intercept, you're going to let all the x's equal 0. Okay? So it looks like this. So that would be negative 2 times negative 6 times 2 times 7. So this is 12. This is 14. And 12 times 14 is, I don't know. I can't think. Oh my gosh, I just hit. Sorry. 12 times 14. let's do 12 times 14. 12 times 14 is 168. All right, so the y-intercept is 168. So let's pick a good scale to go by on the y's. Let's go by 40s. 40, 80, 120, 160, 200. So 168 is about right there. Okay? What do they want to know? Zeros and end behavior. So these are 4 zeros. This is a y-intercept. Some people call that a 0, but I just call it a y-intercept. And then end behavior. So remember, it was a degree of 4. So my ends are going to go like this. Okay, they're up here. Can you guys see these? Oh, my ends are both up here. Those are my hands. So I'm going to start with the left one. None of these are double roots, so they're going to go through. And I'm not using a calculator, so we're just going to estimate that it's going to go down below these 2 zeros. It comes up and hits the y-intercept, and it goes down through the 0, comes back up. End behavior, they're both up. It hits the 4 zeros and the y-intercept. And that's what a degree of 4 looks like. You can graph it if you want, but I'm not asking about mins and maxes, so I'm not going to waste my time graphing on the calculator. 7, find the real zeros of the quadratic function. So quadratic means that you can factor. If you can't factor, then you can use the quadratic formula to figure out your zeros. Or, last resort, use your calculator. So I'm going to try to attempt to factor this. So the first thing I'm going to do is let this equal to 0. And then I'm going to factor. Okay, we can do this out of calculator, just finding the zeros. So you split x squared up. Now over here, we're going to find factors of negative 28 that have a sum of your middle term, negative 3. So for example, like negative 28 and 1, 28 and negative 1, 7 and negative 4, negative 7 and 4, 14 and 2, negative 14 and 2. These are all factors of negative 28. Which ones add up to negative 3? There's only one. Right there. They have a sum of negative 3. So those are the ones we use. So it's going to be negative 7 and positive 4. So what are your zeros? Well, you're going to take this factor and set it equal to 0. You're going to take this factor equal to 0. So 7 and negative 4 are your zeros. So that means, without using a calculator, that 7 and negative 4 are my zeros. My y-intercept is negative 28. I'll go by 4s. 4, 8, 12, 16, 20, 24, 28. And it's quadratic. Now I'm not sure what the vertex is, but the vertex is somewhere in between these 2 zeros. So in between 7 and negative 4, let's think. It's 1.5, I think. So somewhere down here is a vertex. And your graph's going to look like that. So you could graph it just to double check to see if what you're thinking is right. So you could go x squared minus 3x minus 28. Zoom 6. Now I'm not seeing that negative 28 down there, guys. It's way down there. So I'd probably go window, y min, negative 60. What the heck? Let's just go way down there. There we go. So if you wanted to find that vertex, you could by pressing second trace min. Let's go between 0 and 5. So the min is 1.5 and negative 30. So remember I said 1.5 was the middle, so it's about negative 30, so it's about right there. So you're close. And there you go. But what they wanted to know was what your zeros were and know a little bit about your end behaviors to be able to draw that. Okay, so now we're number 9. Number 9, sorry about that. I'm just giving you guys a headache. So this problem is x squared minus 3. So this time I can't factor. This is a difference of a square, but this 3 is not a square, so this is not factorable. So not factorable. So what you're going to do is going to let f of x equal 0. And if there's no third term, if it's not a trinomial, you can just start solving for x. So I'm going to actually write it like this. I don't like the 0 on that side. So here's what we have. So we're going to add 3 to the other side, and you're going to square root. So your zeros are plus or minus square root of 3, which is about We'll say about 1.7 on both sides, positive and negative. My y-intercept's -3, so my guess is you're going to have a graph that looks like that. So let's look. Let's graph it. Clear. X squared minus 3. Okay, I'm going to press zoom 6 again. Zoom 6. There we go. Does it look like it's going about 1.7? Negative 1.7? If you did the 0, second trace 0, let's find this one right here. I think it's between 1 and 3. There it is, 1.7. What is 1.7? You know what that x0 is? That's what square root of 3 is. That whole decimal is square root of 3. Now square root of 3 is the exact answer, so I would want on this problem for you to give me the exact zeros. So 11 is f of x equals x cubed plus 5x squared minus 9x minus 45. Now sometimes you can factor and sometimes you have to use a calculator, but this one says find the real zeros. Notice I don't ask for the imaginaries. So how many real zeros could there be? At most, there are 3. At most, there are 3. Okay? So before I go to the calculator, because the calculator takes a while, I'm going to factor this by grouping. Factor by grouping. Whenever you have 4 terms, you factor by grouping. This is the only time I do grouping. So we're going to group the first 2 plus the last 2. When you factor by grouping, it should always be a sum of the 2 pairs. Take a GCF out of the first pair. The GCF of the first pair is x squared, and you're left with x plus 5. In order for this to work, you have to have another x plus 5 over here. So what would we need to take out to get a 5? I would have to take out a -9. And this would end up being x plus 5. So what you're going to notice here is that this is still a binomial. This is one term, and this is one term. Do you see how there's an x plus 5 in both terms? That is called a binomial GCF, and that comes out front. Or it's called a linear factor. If you remove that from the first term, you get x squared. If you remove it from the second term, you get -9. These are your factors. Now this is a linear factor. This one can go further. See how this is a difference of 2 squares? Difference of 2 squares. Hopefully you know how to factor a difference of 2 squares. X and x, plus 3 and minus 3. Now you have 3 linear factors. Once you get it into linear factor mode, then you can tell me your zeros. -5, -3, and 3. Those are your zeros. And remember how we said there was at least 3? We found them all. There's no imaginary roots here. So before I even punch this in the calculator, I should be seeing it cross there, here, and here. And the y-intercept's -45, so we'll go by 9s. 18, 27, 36, 45. So let's see, the end behaviors would be cubic, one here and one here. So it's going to look something like this. That's what it's going to look like before I even punch it in the calculator. So let's double check that. So you have x to the third plus 5x to the second minus 9x minus 45. So I have it all graphed in there. And I'm going to press graph. All right. Did I not punch them? Okay, something's not right. X cubed plus 5x squared. Oops, this is supposed to be a minus 9x. My fault. See, I knew something was wrong. Thank God I did that rough sketch first, or I would have missed this one. All right, oh, there we go. So do you guys see it hitting at -5, -3, and 3? Look at my end behaviors. That's because it's cubic and leading coefficient's positive. Now, I can't see my min. So if you want to see your min, you go to Window, X min. Let's go -50. And now I should see -5, -3, hitting that y-intercept, which I said, by the way, was -45. Okay, you might have to find your min and max eventually, but that's what your graph looks like. And I kind of already knew that because I found the zeros by factoring. Okay, 13 is x to the third minus 8. You may forget how to do this cubic one, but when you do cubics, you factor it with a by and a try. Do you remember the word SOAP? SOAP comes into play when you do difference or sum of two cubes. SOAP means S means same, O means opposite, and AP means always positive. Same, opposite, always positive. So what does same mean? In the binomial, same means whatever the problem is, if that's a difference, this is a difference. Same. Opposite means the middle term over here should be opposite this. Same, opposite. Third term's always positive. Okay, so this is going to be a minus, positive, positive. Then, when you have cubes, think of x cubed as 3 linear factors of x. What's a number that you multiply 3 times to get 8? 2, you're correct, 2, 2, 2. So in the binomial, you're going to take one of each of these factors, x and 2. Cross them out. In the first slot of the trinomial is the other two x's. That goes here. And then in the last slot, the other two 2's. 2 times 2 is 4, goes there. The middle term is one of these and one of these multiplied together. And that's 2x. And that's how you factor a difference of 2 cubes. So what is the only real zero? This is the only real zero. This one right here is actually going to be 2 imaginary roots. It cannot be factored any further ever on a difference of 2 cubes. This is the only real root. And the real root is 2. If you set that equal to 0. So what I would see on my graphing calculator is 2. It is not a triple root because there's 2 other roots that are imaginary. So you're going to have 1 real root, 2 imaginary. They said only find the real roots in these problems, so the answer is 2. If I wanted to graph this looking at n behavior, because that's cubic, I'm going to have, okay, the y-intercept's negative 8, 3, 4, 5, 6, 7, 8. So you're going to have a graph that does this. All right, that's not a very good graph, so I'm gonna graph this again. 13. 1, 2, 3, 4, 5, 6, 7, 8. And it hits 2. So it's going to look something like that. Let's see what it looks like. X cubed minus 8. All right, press zoom 6. So it's got a little bit more of a curve at the bottom there, so that's okay. We can do that. So we just make it a little bit more curvy right here, but it's going to come through that 3 straight. Oh my God, you can't see that. So it has a little bit of a hook there, but it comes up here. There is no min and max in this problem. There's no min and max in this problem. You have 2 min. Well, you might. You know what? There might be. This could be a min and a max here. We'd have to actually see what that is happening there, but I'm not going to ask that right now. All right, we are now at 15. This is another 4-termer, so we're going to factor by grouping. So pair your first 2 up. Pair your second 2 up. What's the GCF in the first pair? X squared. You're right. So we would get 4x minus 1. Now in order to do this right, you need to get another 4x minus 1 in the other grouping. So what's the GCF of these two? 9. And you get 4x minus 1. There is that magic 4x minus 1. So now the GCF of these 2 terms is 4x minus 1. So you bring that out front, and you're left with x squared plus 9. Now this problem said factor and find the real zeros. If you set your first factor equal to 0 and solved, you would get 4x equals 1 and x is 1/4. That's a real zero. If you set x squared plus 9 equal to 0 and subtract 9, you get this. And if you square root, you get x equals plus or minus 3i. These are imaginary. It says give me the real root only, so you'd give me 1/4. If you graph this, it will only cross at 1/4 because the other 2 answers are imaginary. Remember, there's 3 answers. 1's real, 2 are imaginary. And 17 is x to the fourth minus 34x squared plus 225. By factoring this, you're going to split up the x to the fourth. It's a trinomial, so equally x squared and x squared. Cubes are not split up equally, but even exponents are always split up equally for the exponents. Factors of 225 that add up to 34. First of all, because it's positive 225, they both have to be positive. They both can be negative because this is negative. So like you wouldn't use 225 and 1, that's too big. But maybe like 25 times what is 225? 9. They would both have to be negative. That actually equals negative 34. So it's negative 25 and negative 9. Set each one equal to 0. And solve. So this one's x squared equals 25. And 2 of your answers are plus or minus 5. This one, you add 9, and x equals plus or minus 3. So your 4 zeros are negative 5, negative 3, 3, and 5. The y-intercept's 225, so I'll go by hundreds. So it's like right there, and your ends go like this. So like something like that. And that'll be what your graph looks like. Done.